welcome to the video on all about the periodic table. So I mentioned previously that if there is one main thing that I would like for you to take from this course, of course I would like for you to take lots of different concepts from the course, but one big one would be to understand the periodic table and all the things that it can tell us and help us with understanding elements and reactivity. Alright, so here's some basic features, and we're going to add to this through the semester. And you will need a periodic table, so please have one out with you and that you're looking at. Okay, I'm going to show one here, but it's best if you're even looking at one now. Okay, a row, okay, that goes from left to right in a periodic table is called a period, and a column, up to bottom, is called a group. Okay, in your periodic table. You have main group elements, so if you look at your periodic table you'll see these, and they are the tall columns, and they're numbered 1A through 8A. Okay, and these are the elements that we mostly deal with in an introductory course because they have typical trends and behavior, and we can understand their bonding and their reactivity. Your transition metal elements, sort of in the middle there, these are the short columns, and they are grouped by 1B to 8B, and they're also called non-representative elements, and your main group are sometimes called representative elements. Okay, you have intertransition elements, and these are the lanthanides and actinides, and they have no group numbers that are assigned, and we don't do a lot with those in this class. Alright, so here what I'm talking about. So let's point it out. So a group runs this way, so this is group 1A. Okay, they run vertical. Okay, periods run horizontal. Okay, your first period here is going across this top. Students often forget that. They want to start here. Okay, so that's your first period. Here's your second, third, fourth, and so on. Okay. In blue, okay, it just happens if you have 1A, 2A, then you skip over to 3A, 4, 5, 6, 7, and 8. So these columns here and here are your representative or your main group elements. These are transition metals. They are all metals, hence the name. Okay, and see how these have B there. Okay, some of our groups have a common name that they go by, and we're going to look at the periodic table again to look at those. And one thing I also want to point out is the chemical properties of elements in a group are very similar. Okay, and so they react very similar to each other. Okay, and we'll talk more about why that is later. But if you look at your 1A, okay, group, so if I'm going to go back here, okay, these are called the alkali metals, and group 2A apologize for that long, whoops, there we go. Okay, and then if we skip over here to group 7A, okay, these have a common name. This whole, okay, when we're talking about the whole group here. Okay, that's alkali, then alkaline, and then these are, this whole group 7A are called halogens. It's A, H-A-L-O-G-E-N-S. And then group 8A, this whole group here, are called noble gases. Alright, I wanted to go ahead and point those out. Okay. The alkali and alkaline metals, they are metals, so they are soft, shiny, low melting points, good conductors of heat and electricity. They also react with water. Halogens, These are very reactive, and so we'll learn more about why that is with their bonding patterns later. But they are very reactive, and they usually, or they do exist as what we call, these are called diatomic molecules, meaning the same element bonded to itself. Okay? And they are so reactive that they exist this way, and their bonding patterns, the reason that they are F2, not just F, is because it wants to be that way to be stable. All right, your noble gases, however, your 8A column, or excuse me, group that I showed you, these are very stable, so they rarely combine with any other element. So these are the most stable, okay, of the elements on the periodic table. Carbon is an unusual element, and so unusual that you can spend years and years of studying just carbon, and that's what we start doing in organic chemistry if you take that later on. My graduate degree is in organic chemistry, so that is my passion, of course. But this is just a little bit about carbon and how it has ability to bond to itself and make long chains of carbon chains. Okay, carbon, it always wants to make 4 bonds. So when we start learning about bonds, that's also another point about it. And it can combine with all these other elements as well. So carbon and hydrogen and oxygen and nitrogen and so on. And it also exists, so these are carbon-only structures. So you can see here, it can exist a diamond, graphite, okay, and this as well. Okay, and so it's just very unique. It's one of the most unique, in my opinion, on the periodic table. All right, so here's some practice just using the periodic table, what we've learned so far. Okay, we want to look at our periodic table, and we want to find the element that has an atomic weight of 132.9. So this is just kind of putting things together that you've hopefully learned through the videos so far. Okay, we want to look for that. So you may want to write all these down, or if you have your periodic table with you, then you may not have to or have this printed out. Okay, but I'm going to try to remember the questions and go back to my periodic table. Okay, and I don't know if I can delete here. All right, so be looking now for the element that has an atomic weight of 132. All right, atomic weight comes from, that number is the average of the isotopes, the average mass of the isotopes, and it is on the periodic table. So we need to look for 132.9. So the answer would be cesium. And you could just write the element CS. All right, now I'm looking for an element with 74 electrons, if I remember correct. Okay, if it's neutral, and it should have said that in the little practice questions, if it is a neutral, then it has 74 protons and 74 electrons. So we would find this one, and you could just write W there. All right, this element has an atomic number of 37. Right, so that one should be pretty easy. We know that number here is the number of protons, or the atomic number. All right, the next one, I believe we were given a mass number of 128. Okay, the mass number is number of protons plus neutrons, and we were given that it had 84 neutrons. Okay, so 128 minus 84 gives us 44 protons. Okay, so if we go find 44 as our atomic number, or number of protons, we get ruthenium. Okay, so here, if we're given the total mass number, since it's equal to protons plus neutrons, we can just subtract the number of neutrons to find the protons, and then that's the identity of the element, and there it is. All right, we now want the halogen in the fourth period. So this tests two things. All right, do you know where the halogens are? Okay, halogens are your group 7A. Your fourth period, you cannot forget about this first one here that runs across. So we go 1, 2, 3, 4. Okay, so there's my fourth period. Then I come over and I find my halogen that's in the fourth period, and it would be bromine. Okay, the next one was any two noble gases. So here's my noble gases in 8A. It's just testing that you know where your noble gases are. So you could write helium, neon, argon, so any of those there. All right, and then the next one is looking for alkali metals. Okay, and I chose this on purpose because hydrogen has a hard time finding a home. So sometimes you'll see it in the middle just because it is not. So of all of these, and I meant to mention this earlier, in this group, okay, the metals start here. Okay, hydrogen is not a metal. Okay, it is a non-metal. Okay, sometimes you'll see it in a periodic table and they'll actually put it right here. Okay, but then that's not a good place either because it has one proton. It's the first one, so it has a hard time. Sometimes you see it in the middle there, but it is not a metal. So your alkali metals start here, and I think you could name two or how many ever I told you, but any of these would be fine. So you would do lithium, sodium, potassium, any of those. Okay, but do not put hydrogen as an alkali metal, okay, because it is a non-metal. It just has a hard time finding a home. So I hope this helps and you are beginning to learn more about the periodic table, and hopefully we will expand on this and you'll learn more and more. Thank you.